Setting out main points of a circular curve. Hi there. Let's take a look at the following pictures. It can be seen that roads, railways, bridges, canals, and other common buildings and structures in daily life inevitably need to change directions. In order to adapt to the local conditions and for safety reasons, it is necessary to connect them with curves so that routes slowly change directions along the curves. Curves are designed in various forms, and the circular curves are commonly used. Today, let's learn about the setting out of main points of a circular curve. First, let's understand the concept of a circular curve. The arc with a fixed radius that is set up to connect two adjacent straight line sections when a circular curve route changes direction horizontally or the grade changes vertically is called circular curve. Let's combine the following figures to understand the circular curve. The straight line in the figure goes from point A to point JD, then turns in the direction from JD to B. The two straight lines are connected with a circular curve with a radius r. ZY is the tangent point where line A turns to the curve, and is called the starting point of circular curve. YZ is the point where the curve turns to a straight line B, and is called the midpoint of circular curve. QZ is the midpoint of curve, JD is the intersection point of curve. Point of curve, midpoint of curve and point of tangent are the key points that control the position, shape and alignment of the curve, namely the main points of circular curve. After understanding the concept of a circular curve, how do we set out the key points that control the position, shape and alignment of curve on the ground? Next, let's learn the setting out process of the main points of a circular curve. To determine the positions of the main points, you must know the 6 elements of a circular curve. R. Curve radius, selected by designers based on terrain conditions and engineering requirements. Alpha, yaw angle, measured during the route survey phase. T is the length of the tangent, equal to the radius multiplied by the tangent of half the turning angle. L is the length of curve, equal to the radius multiplied by the turning angle and then multiplied by pi divided by 180 degrees. E is the lateral distance, equal to the secant of half the turning angle minus 1, and then multiplied by the radius. Q is the curvature difference, equal to double tangent lengths minus the curve length. In actual work, the point numbers on routes are represented by milestone markers. So what is a milestone marker? The milestone marker refers to the distance from this point to the starting point of the route. Generally, the milestone marker at the starting point is 0 plus 000. The number before the plus sign represents the kilometers, and the number after the plus sign represents the meters. For example, 2 plus 200 means the distance from this point to the starting point is 2 kilometers and 200 meters, or 2,200 meters. Therefore, in addition to the 6 elements of a circular curve, it is also necessary to know the milestone markers of the main points. The milestone markers of the main points can be calculated using the following formula. The milestone markers of the main points can be calculated and checked using the difference of the tangent and curve Q. The setting out process of main points of a circular curve is as follows. 1. Set out the starting point of a circular curve. Place the instrument at the intersection, rotate the alidade to aim at point A, break the alidade, and set the horizontal circle to 0 degrees 0 minutes 0 seconds. Move the telescope up and down to command the orientation. Starting from the intersection, measure the tangent length t in the direction of the tangent line, obtain the point of curve, and mark it by driving in a peg. 2. Set out the endpoint of curve of a circular curve, rotate the alidade to aim at point B, break the alidade and rotate the telescope to command the orientation. Starting from the intersection, measure the tangent length t in the direction of the tangent line, obtain the point of curve, and mark it by driving in a peg. 3. Set out the midpoint q of a circular curve, keep the instrument fixed at point B, set the horizontal circle to 0 and rotate the alidade clockwise, so that the reading on the circle is. Get the direction of the midpoint of curve. Measure at this point the external ordinate E from the intersection point, determine the point QZ, and mark it by driving in a peg. I hope that through this lecture, you can master the methods for setting out the main points of a circular curve. After class, you can further improve the understanding of specific operation process of setting out main points of a circular curve through practical experiments, and complete the post-class knowledge expansion tasks.